folks, in this video we're going to go over the product and quotient rules. So the product rule, which we'll get into first, is used whenever you have two functions multiplying each other. So the product rule says, let h of x be f times g. Okay, so we're multiplying two functions. Then the derivative of that function will be, you take the derivative of the first part of your function, multiply it by that second function, left alone, plus, now you take the derivative of that second function and multiply it by the first function, left alone. Alright? Well, if you're confused about all the f's and g's, I like to think of it in terms of this. Let's say h of x is some function a times some function b. Okay? So let's say h of x is a times b. The product rule is telling you this is simply a prime times b plus b prime, let's make that a plus b prime times a. And so what that means is you take the derivative of one of the functions, multiply by the other left alone, plus, and then you do the vice versa. Okay? But the key with the product rule is, notice you're taking just one derivative at a time, and then essentially what you're doing is you're distributing the derivatives, what you're doing here. All right, let's get into a few examples here. For example, we have x squared, f of x equals x squared plus 4 times x squared minus 2x. And what we're going to do here is I'm going to label these. So we're going to call x squared plus 4 our a. The x squared minus 2x, I like to call that b. Okay. And so then we know f prime of x, we have to use the product rule. We're going to do, well, we don't have to use the product rule. Instead, what we could do is we could distribute and then do our sum and difference rule, but I want to practice the product rule. So a prime. So what's the derivative of x squared plus 4? The derivative will be a 2x. Okay, and that's going to multiply the b function left alone, x squared minus 2x. Okay, so I think it's helpful to label up your work. So this is a prime times b. Now plus, now we take the derivative of that second function, that b function there. So we have to take the derivative of x squared minus 2x, and that derivative will be a 2x minus 2. Okay. I'm putting that in parentheses because I need that entire factor, b prime, to multiply our a, which is the x squared plus 4. And there we go, folks. That is your product rule. Okay, a prime times b plus b prime times a. All right, let's look at another example here. All right, so h of x is, let's see here, f times g. Let f of 2 equal 4, g of 2 equals negative 2, f prime of 2 equal negative 1, g prime of 2 equals 5. Evaluate h prime of 2. So this is a bit more abstract because we don't have the actual f of x and g of x functions. Instead, we have like their evaluations. But we're going to start off with the same thing. So we know that h of x is f of x times g of x. Okay? And we know that the product rule says that this derivative has to be f prime of x times g of x left alone plus g prime of x times f of x left alone. I'm just doing the product rule there. And so if they want us to evaluate h prime of 2, what that means is that we just need to plug in a 2 everywhere for x. So we're looking at h prime of 2 has to equal f prime of 2 times g of 2 plus g prime of 2 times f of 2. Okay? And now we're going to utilize all of this information that they gave us at the beginning of the problem. All of this information here that I'm highlighting we're going to use. All right, let's plug everything in. So h prime of 2 equals, well, what's f prime of 2? F prime of 2 is equal to a negative 1. So it's going to be negative 1 times, let's see here, g of 2. They told us g of 2 is a negative 2. Plus g prime of 2. Let's see, g prime of 2 is 5. Times f of 2. And they told us f of 2 is 4. Okay, so make sure you plug these in the correct spot. All that's left for us to do is to go ahead and multiply this out. Negative 1 times negative 2 is a positive 2 plus 20. 5 times 4 is 20. So h prime of 2 is 22. So hopefully that one wasn't too bad. So just whenever they give you all these ordered pairs, all these function values, just go ahead and do your product rule and then just plug in the values into the correct places. All right. Oh, here's a good one. Another example. So f of x is 3x plus 4 to the third power times 6x minus 1 to the fourth. I want you to find f prime of x and simplify your answer via factoring. All right. So once again here, we have to do a product rule. But as we're doing a product rule, we're going to notice that, hey, when we start to take these derivatives, these individual factors here, they're going to actually involve us using a chain rule. They're going to involve us using a chain rule because of these powers outside the parentheses. But let's take it one step at a time here, okay? So 3x plus 4, that's A. 6x minus 1 to the fourth, that's B. Here we go. What's our derivative? Product rule. So to take the derivative of 3x plus 4 to the third power, we're going to need to do the chain rule. So the chain rule says you bring your power 3 out front, leave your inside alone, but raise it to the one less power, and then you multiply it by the derivative of the inside. So the derivative of 3x plus 4 is 3. Okay? So all of what we just did, I know we did a lot there, but everything that we just did, this is just a prime. Okay? And I want to be clear here. Where did this 3 right here came from? It came from the derivative of 3x plus 4. Okay? Where did the 3 out front come from? That 3 came from the original power of 3 that we had for our factor there. Okay, so A prime times B left alone. So B is going to be, no pun intended, 6x minus 1 to the fourth power. All right, I'm about to shrink this a little bit because I'm going to need some more space. All right, plus, well, let me label out what I'm doing. I'm sorry. So this chunk right here is just B plus B prime. Okay, so now we are taking the derivative of 6x minus 1 to the fourth. We're taking the derivative of 6x minus 1 to the fourth. So that's going to be 4, comes out front, 6x minus 1 to now the third power. And then the derivative of the inside, derivative of 6x minus 1 is just a 6. Okay, so one more time. Let's grab a different color. This 6 came from the derivative of 6x minus 1. All right, all that we just did there, all of that chain rule is just B prime, but we're not done with the product rule. We still need to multiply it by the A factor, which is 3x plus 4 to the third power. Okay, and then this is your A term. All right, so that is the derivative, but the instructions say, let's take it one step further. Let's simplify our answer by factoring. Okay, and so what do I mean by factoring here is I mean the greatest common factor. Okay, I mean the greatest common factor. So for example, real quick, we'll come back to this one. For example, let's say we had, I don't know, 4x squared y cubed z plus 8 y squared z x. Let's say we had that. Okay, so I like to circle up my plus to differentiate my first term from my second term. But to pull out the greatest common factor, we need something that's in common on both sides of the plus sign that we just circled. Well, certainly we have a 4 in common because we have a 4 and an 8. So we can factor out 4. Okay, what else can we factor out? We have an x squared on the right, on the left term. We have just an x to the first in the second term. So we can pull out an x to the first. Because remember, we're trying to pull out the greatest common factor. We got a y cubed on the left. We have a y squared on the right, so we can pull out a y squared. And then we have a z to the first on the left side. We have a z to the first on the right side, so we could definitely pull out a z to the first. Okay, so what's left over? What's the remaining factors left over once we divide out our common factor? Okay, so I want you to focus on just this part. I'm working with just this part of what we're talking about, okay? Greatest common factoring is dividing, okay? I take the 4, here, let's do it this way. I take this 4, and I divide it by my common factor of 4. That leaves me with a factor of 1. Okay, you don't have to write the factor of 1, but I'm just going to leave it in there just for clarification purposes. All right, same thing. We're going to keep it moving. I have an x squared here, but I need to divide it by an x to the first. X squared divided by x to the first leaves us with the factor of x. And so on and so forth. I hope you're starting to see the pattern. Y cubed gets divided by y to the second. That leaves us with y to the first. And then z to the first gets divided by z to the first. That leaves us with a factor of, not 0, leaves you with a factor of 1. Okay? Now we bring down our plus, and now we do the same thing on the other side of the plus sign. Let's get a different color. Let's do yellow. All right, I take 8 divided by 4. 8 divided by 4 leaves us with a factor of 2. We take y squared. It gets divided by y squared. That leaves us with a factor of 1. And then we have z, which is divided by the z in the common factor. That leaves you with another factor of 1. And lastly, we have x, which is divided by x to the first, and that also leaves us with a factor of 1. Okay? And then we would clean all of that up, right? We would simply say that this is equal to 4x y squared z times 1 times x times y times 1, that's just xy, plus 2 times 1 times 1 times 1 is just 2. Boom, there you go. 4xy squared z times xy plus 2. Okay, we're going to do that exact same thing with our derivative up here, okay? We just want to find common factors. So I'll give you a second to maybe take a screenshot of this because I'm about to erase the work that we just did. Okay, all right, so here we go. Let's now pull out the greatest common factor from our derivative and use that to simplify our answer. Here we go. All right, so same thing as before. I'm going to circle up my plus. Let's focus on what's to the left and to the right of the plus, and let's see what's in common. Okay, so I notice this. I have a 3 here and a 3 here. Those 3's are going to multiply to give us 9. On the right term, I have 4 times 6. That's going to give us 24. So the question becomes, what's the greatest common factor between 9 and 24? And that answer is a 3, a factor of 3. Okay, once again, 3 times 3 is 9. 4 times 6 is 24. Greatest common factor is 3. Okay, we have a 3 x plus 4 squared on the left. We have a 3x plus 4 to the third on the right. That means we could pull out a 3x plus 4 to the second power. Once again, we're trying to get a greatest common factor. And then we have a 6x minus 1 to the fourth on the left, 6x minus 1 to the third on the right. That means we have a greatest common factor of 6x minus 1 to the third. Okay, here we go. Now we need to figure out what's left over. What's left over? Okay, so remember, what do we do? Remember that we took 3 times 3 out was 9, but we divided out, we took out a factor of 3. So 9 divided by 3 leaves you with a factor of 3. Okay, we only took out one of those 3's. You take 3x plus 4 to the second power, you divide that by 3x plus 4 to the second power. That's going to leave you with a factor of 1. Right? When you divide the same thing, you get 1. And then 6x minus 1 to the fourth divided by 6x minus 1 to the third leaves you with the 6x minus 1 to the first power. All right? Okay, I'm bringing down my plus, and I'm doing the same thing now. I'm taking the right side, and I'm dividing it by my greatest common factor. 4 times 6 is 24. Let me come up here. 4 times 6 is 24. 24 divided by that factor of 3, that's our greatest common factor, leaves us with a factor of 8. 24 divided by 3 is 8. 6x minus 1 to the third divided by 6x minus 1 to the third leaves us with a factor of 1. 3x plus 4 to the third divided by 3x plus 4 to the second leaves us with the 3x plus 4 to the understood first power. And there we go. That closes it up for us. Now in the remaining steps, all I'm going to do is just clean up, simplify my brackets. But the hard work is done. All right, 3 times 3x plus 4 to the second times 6x minus 1 to the third. Okay. 3 times 1 is 3, and I'm just going to take that 3 and distribute it to my parentheses in the 6x minus 1. 3 times 6x is 18x. 3 times a negative 1 is a negative 3. Plus, 8 times 1 is 8, so I'm just going to take the 8 and distribute it to that set of parentheses. 8 times 3x is a 24x. 8 times, let's see, that's a 4, so 8 times 4 is a 32. All right, and then all that's left for us to do is combine the like terms within the brackets, and I'm just going to go ahead and convert my brackets over to parentheses. There's no difference between brackets and parentheses. I just like brackets because they just make things look a little different. But 18x plus 24x, that gives us 42x. Please check my math. A negative 3 plus 32 is a positive 29. So this is our fully simplified, well, not fully simplified, but that is our simplified derivative there via factoring. Okay, so that is the product rule. Next, let's talk about the quotient rule. And we'll only do a couple quick examples of this. The quotient rule says, let h of x consist of a rational function, a quotient, right? It's f of x divided by g of x. Well, it turns out that h prime of x equals, it's g of x times f prime of x minus f of x times g prime of x, all divided by g of x squared. I know, that's a mouthful, okay? So, but the concepts are similar to the product rule in that you're only taking one derivative at a time. You're not just taking two derivatives and dividing them. That's not what you do. But for sake of a mnemonic device to kind of help you memorize this, is I like to think of it in terms of this. I'm going to go back to h of x. I'm going to call f of x, I'm going to call that my high function. I'm going to call g of x my low function. And I like to think of the quotient rule as being kind of like a yodel. And what do I mean by that? Is because h prime of x equals, okay, it's low d high minus high d low over low, or what I like to call low squared. What does this mean? This means you take your low function left alone, you take your denominator left alone, but it multiplies the derivative of the high. So d means derivative. You take the derivative of the high, it multiplies the low function. Minus, very important, not plus but minus, now you take your high function left alone, and it multiplies the derivative of the low function. And then you divide that entire difference by your low function squared. So that's how you perform the quotient rule. Some examples here. Here we go. For example, f of x is 5x squared plus 7 divided by 4x plus 3. Okay? Low d high minus high d low over low low. All right? You always start from the bottom. Start from the bottom, just like a great philosopher once said. I believe his name is Aubrey Graham. All right, so start from the bottom. Here we go. F prime of x is low. So it's 4x plus 3 in parentheses times d high. I have to take the derivative of my numerator, derivative of my high function. The derivative of 5x squared is 2 times 5 is 10. It's a 10x to the first, and the derivative of 7 is 0. So there we go. Let's label this up, actually. This is low d high minus high 5x squared plus 7 times d low. So the derivative of 4x plus 3 is just a 4. Once again, labeling helps. So this is high d low. And we put this entire difference over low squared. So simply just put it as a 4x plus 3 quantity squared. Okay? Alright, I guess I'll take it one step further here, but the key I want you guys to understand is how to apply the rule. Now what I'm going to do is, I'll clean this up a little bit. I'm going to take my 10x, and I'm going to distribute it to the 4x plus 3. And then, be careful here, I'm going to take a negative 4, and I'm going to distribute that to the second set of parentheses. Okay, I'm taking a negative 4 because of that subtraction sign. So here we go. 10x times 4x, that's a 40x squared, plus 10x times 3 is 30x. And now let's distribute that negative 4. Negative 4 times a 5x squared, that's a negative 20x squared. And a negative 4 times 7 is a negative 28 over And do not FOIL out the 4x plus 3 squared. Let's just leave that alone. Combine like terms and we're done. 40x squared plus minus 20x squared leaves us with a positive 20x squared plus 30x minus 28 over 4x plus 3 quantity squared. Folks, that is your quotient rule, aka the yodel. Low D high minus high D low over low squared. Alright, I believe this is the last question. Alright, so this is similar to what we had earlier with the product rule. Here they give us, oh man, all kinds of function evaluations. They want us to find h prime of 2 whenever h of x is a quotient. That's okay, we got that. So once again, let's do our product rule. So quotient rule. So h prime of x is low D high. So g of x times f prime of x minus high D low, f of x times g prime of x over, do not forget this part, over low squared, over g of x quantity squared. Okay? So if we need to find h prime of 2, it's g of 2 times f prime of 2 minus f of 2 times g prime of 2 over g of 2 squared. So all I've done here is just plugged in 2 for x. And now this is just a matter of plugging in the correct evaluations in the right place. So g of 2, what's g of 2? They told us g of 2 is a negative 2, so it's a negative 2 times f prime of 2, which is a negative 1, minus f of 2, which is 4, times g prime of 2, which is a 5, over g of 2 squared. G of 2 was negative 2, and we're going to square it up. Okay, negative 2 times negative 1 is a positive 2. A negative 4 times 5 is a negative 20. Over, be careful here, a negative 2, that quantity squared is a negative 2 times a negative 2. That's a positive 4. Okay, so then we have, let's see, negative 18 over 4. Let's go ahead and reduce that. Divide the top and bottom by 2. You get a negative 9 halves. And that is what h prime of 2 equals. Alrighty, folks, apologize for the length of this video, but I wanted to be extra clear with you guys on how to perform the product and quotient rule. I'll see you guys in the next one.